In the previous video, we have learned about the odd electron molecules. In this video, we're going to talk about expanded octet. Atoms of the second period elements cannot have more than 8 valence electrons around the central atom. But atoms of elements in and beyond the third period of the periodic table form some compounds in which more than 8 electrons surround the central atom. One compound in which there is an expanded octet is sulfur hexafluoride. So let us draw the Lewis structure for sulfur hexafluoride. Sulfur has 6 valence electrons. Fluorine has 7 valence electrons. Multiply it with 6. So we'll have 48 valence electrons for the sulfur hexafluoride molecule. Let us now draw the skeletal structure for sulfur hexafluoride, wherein sulfur is the central atom, surrounded by 6 fluorine atoms. So in this skeletal structure, we have 6 bond pairs for a total of 12 electrons. So we need to add 36 more electrons in our skeletal structure. Since the fluorine atom has a single bond with the sulfur atom, we just need to add 3 lone pairs for each fluorine atom. And then let's double check the number of electrons for each atoms in the SF6 molecule. So we have 2, 4, 6, 8 electrons for this fluorine atom. And these fluorine atoms are identical. So all of them has 8 electrons. However, for our sulfur atom, we have 6 bond pairs, which means that we have an expanded octet for the sulfur atom, which has a total of 12 electrons. Another example of the expanded octet is the ion sulfate. Let us now determine the valence electron for the sulfate ion. Sulfur has 6 valence electrons. Oxygen has also 6 valence electrons. Multiply it by 4. Since we have a negative charge of 2, we are going to add 2 more electrons. So we now have a total of 32 electrons for the sulfate ion. Let us now draw the skeletal structure for the sulfate ion, in which sulfur is the central atom, surrounded by 4 oxygen atoms. Now, we have 4 bond pairs for a total of 8 electrons. We still have to add how many electrons to the sulfate ion. So since we have 32 valence electrons, we still have to add 24 electrons to the sulfate ion. So we're going to add 3 lone pairs to each of the oxygen atoms. That will give us a total of 24 electrons. There is also another Lewis structure for the sulfate ion. So what we're going to do is, again, to determine which of the two is a more plausible structure for the sulfate ion. Let's start with the structure. So This oxygen atom has a -1 formal charge because it has 6 valence electrons and 7 assigned electrons. That will give us a -1 formal charge for this oxygen atom. Since these atoms or these oxygen atoms are identical, all of them has a -1 charge. For the sulfur atom, we have 6 valence electrons minus 4 assigned electrons. That will give us a negative or a +2 charge for the sulfur atom. So take note of the total formal charges of all the atoms. It is equivalent to -2, which is the same with the charge of the sulfate ion. How about on the second Lewis structure? This oxygen atom has a 0 formal charge because it has 6 valence electrons and 6 assigned electrons. This oxygen atom is identical to this oxygen atom, so that means this also has a 0 formal charge. This oxygen atom has a negative formal charge because it has 6 valence electrons and 7 assigned electrons. That will give us a -1 charge. These two are identical, so this means that the formal charge of this oxygen atom is also -1. For the central atom sulfur, we have 6 as the valence electron, and we have 6 assigned electrons. That would give us a 0 formal charge for our sulfur atom. So the total formal charge of this structure is also -2, which is also the same with the charge of the sulfate ion. So if we're going to compare the two Lewis structure, this Lewis structure is a more plausible structure because it has fewer formal charges compared to this Lewis structure.